Okay, hello everyone, welcome back. Then let's talk about what is a game. Game is a concept we borrow from the game scenery. And why we need to care about the game here? The main reason is because the generative adversarial net, this game model is designed based on a game between two different models, between the generative model versus the discriminative model. Then first of all, what is a game? And here we have a page to provide you with some brief information. So the game scenario is the study of the mathematical model for the strategical interaction among different agents. And we have an assumption here. All the agents we are studying in a game, they are selfish, and we decide the actions to maximize their payoffs. And this assumption is very important. In other words, these agents will be working for their own, and they want to maximize their own payoffs. And at the bottom of this page, we have an example of a game between two criminals. Let's assume we have two criminals, they are arrested by a policeman, and the police lacks sufficient evidence actually for their crimes. And these criminals may have different options, right? When they are arrested, they can either, betray each other to tell the truth, or they can remain silent. Depending on the actions they perform, then there will be different results, right? According to the actions. So, for example, if both these two criminals, A and B, they are both, betray each other and to tell the truth to the policeman. If so, because they tell the truth to the policeman and they admit their crimes, right? Then they both will be serving 2 years in the prison. If so, another case that A betrays B, however B remains silent. Then this A, because he betrays B and he tells the truth and he has some contributions, right? And A will be set free and B will be in prison for 3 years. On the other hand, if B betrays A and A remains silent, B will be set free and A will be in prison for 3 years. Another case is that if both A and B they remain silent, then both of them will be serving only 1 year in the prison. So, you can play the game with your friends. Maybe you can form a team to play this together. Then you may imagine what will be the final result. So remember, we have assumption all the agents they are selfish and they will decide the action to maximize their own payoffs, right? Then you can see what will be the potential result. So normally when we decide the result, we have to define a payoff matrix among the agents. Right, among the agents. So before we mentioned we have two criminals, A and B, they have different options, either betray the other or stay silent. Right, depending on the actions, then there will be different results. Right. And here we assume both A and B they are rational and selfish, and they will decide their action to maximize their own payoffs. So we can define their payoff matrix among these two criminals A and B as shown here. So depending on the action, we can have different results. If A stays silent, B stays silent, their payoff will be -1, right? Because they will be in prison for 1 year. They don't want to stay in the prison, so the payoff will be a negative number. If A stays silent, B betrays, then the A's payoff will be -3, right? Because he will be in prison for 3 years. However, B betrays A, he will be set free. And on the other hand, if A betrays and B stays silent, then the payoff for A and B will be 0 and -3, right? If both of them they betray each other, then the payoffs will be -2 for both of them. Right. And still remember, we have assumption both A and B they are selfish, and they want to decide the action to maximize their payoff. Then it will be coming to the intrinsic part. Because, according to different options, for all the actions performed by the two agents, we can have different results. So here we can randomly pick one entry inside the matrix. Now we can pick this one, the first entry, right? -1, -1. So in this case, for this entry, an action performed by both A and B in this entry is that they are both staying silent, right? However, for this entry, let's assume if A thinks about it, alright, let's assume at this moment A thinks about it. Then let's take a look at A's perspective and his action. For this entry, A stays silent. And A finds that if he changes his action from silent to betray, his reward will be maximized, right? Will be increased from -1 to 0, right? In other words, if A changes his action, then his status will be changed from this entry to this entry, and his reward will be increased. We assume this A will be selfish, then this A will change his action from this entry to this one instead, right? In other words, A will betray actually to increase its reward. And then let's take a look at B's action. B finds that when the knight is in this entry, if B changes his action, he will be changed from this entry to this one instead, right? And if B also betrays, then his reward will be increased from -3 to -2 instead. Because here we assume B is also selfish, right? Then in this way, then they will move into this entry, right? They will be moving into this entry, right? Then how about A? If A further changes his action, from betrayed to silent, from this entry to this one, his reward will be decreased, right? In other words, A will no longer be changing his action at all from this one to this one anymore, right? In other words, from this entry, by changing their action to increase their own reward, they will finally convert to this entry as a result, right? And for this case, we consider A first. If we consider B first, from this entry, if we consider B first to change his action, he will move in from this one to this one, because if B changes his action, his reward will be increased from -1 to 0, right? Right. And if we further consider A's action, he will also do the changes of his action to betray and convert to this one. So, for this kind of small game between A and B, they finally will converge to the last entry, -2, -2, and they will betray each other. So, some game will converge to a stationary state, like this one, right? Where they will converge to this entry, right, as a result. And this kind of stationary state is also called Nash Equilibrium. Some of the game will converge to this kind of stationary state. Not all the game will converge to, actually. For each agent, this strategy, this action will be the best possible for the opponent's strategy, actually. Now, this one, they will converge to this entry and they will betray each other so as to maximize their own rewards. Right. So for this kind of game scenario, we have this assumption. This assumption is very important. Besides this small game we show here, for the prisoners dilemmas, we also have some other well-known examples about game scenario, like zero-sum game. And we may also have the extensive application of game scenario in economics, when we do the trading among different agents. Right? So this is some background knowledge about the game scenario.